You've probably heard of bats flying at night, but what you may not know is that they use a superpower to navigate and hunt. Echolocation. Imagine being able to sense the world through sound, like a biological sonar system. Echolocation isn't just a cool trick. It's a survival skill that evolved over millions of years. Bats developed this ability to thrive in dark environments where vision fails, turning sound into an extraordinary map of their surroundings. This ability isn't just for finding food. It's also a way to avoid predators and find safe places to roost. It's a perfect example of how evolution can turn a simple trait into a complex and powerful adaptation. But how exactly does echolocation work? Let's dive into the science and explore the evolutionary journey that gave bats this remarkable ability. So what exactly are we talking about? Echolocation is a superpower, a way of seeing with sound. Bats use it to navigate and find food in the dark, completely relying on echoes to map their world. They emit short, high-frequency calls and listen for the echoes that bounce back from objects. This process is like a sonar system, but with a lot more precision and speed than any human technology. Echolocation is not just about finding insects. It's about understanding their movement, size, and even texture in real time. This makes bats incredibly efficient hunters, especially in the dark. But how did bats evolve this ability? It's believed that echolocation developed as a way to survive in environments where vision wasn't enough, like dense forests or caves with no light. Over time, bats refined their echolocation to be more accurate, allowing them to navigate and hunt with near-perfect precision. It's an evolutionary advantage that's still unmatched in the animal kingdom. You might not realize it, but echolocation in bats is a powerful example of how evolution can solve complex problems with remarkable efficiency. It's not just about surviving in the dark. It's about thriving in ways we can barely imagine. This ability has shaped entire ecosystems. Bats are keystone species, pollinating plants, dispersing seeds, and controlling insect populations. Without them, many of our food sources would vanish. Their echolocation also inspires human innovation. From sonar to medical imaging, the principles of bat sonar have revolutionized technology in ways we now take for granted. Understanding how bats navigate without sight can teach us about sensory perception, adaptation, and even how to improve human technologies in extreme environments. So the next time you hear a bat at night, remember, its silent clicks and calls are more than just a curious sound. They're a testament to nature's ingenuity and a blueprint for human progress. Imagine 50 million years ago, in the dense, shadowy forests of the Eocene epoch. Bats were just beginning to explore the dark with sound, their wings slicing through the air as they hunted for insects. These early bats didn't have eyes to see, but they had something better, a finely tuned sense of hearing. By emitting high-pitched calls and listening for the echoes, they could map the world around them with astonishing precision. As they evolved, their echolocation became more sophisticated. Some bats developed the ability to emit calls in rapid bursts, allowing them to track fast-moving prey with near-perfect accuracy. This ability gave them a huge evolutionary edge. With echolocation, they could hunt in complete darkness, avoiding predators and outcompeting other nocturnal animals for food. Through time, this survival trait became a defining feature of bat evolution. Echolocation allowed them to occupy a niche few others could, a world of darkness where they ruled with sound. Imagine you're in a dark cave, and all you can do is make a sound and listen to what happens next. That's how bats find their way around. The sound bounces back to the bat like an echo, telling it where things are, even if it can't see them. This special way of sensing the world helps them catch insects and avoid danger, even when it's pitch black. Over time, this ability became so good that it helped bats survive and even outsmart their predators. So, the next time you hear a bat squeak, remember, it's not just noise, it's a secret language that helps it explore the world. To start, a bat takes flight with its wings spread wide, ready to begin its nightly hunt. Its body is sleek and agile, built for speed and precision in the dark. Once airborne, it emits a high-pitched sound, like a short, sharp squeak that humans can't hear. This call is more than just noise. It's a tool for navigation and hunting. The bat's ears are especially adapted to capture these returning echoes. Their shape and structure help funnel the sound back to the inner ear, where it's processed instantly. This entire process is controlled by the bat's brain, which interprets the echoes in real time. It's not just hearing. This is a complex system of sensing and reacting to the world around it. Now that the bat emits its sound, the next step is listening. Its ears are tuned to catch the echoes that bounce back from objects in the environment. These echoes are incredibly detailed, containing information about the size, shape, and even texture of whatever is in the bat's path. The bat's brain processes these echoes with remarkable speed, comparing the time delay and intensity of the returning sound to determine distance and movement. This processing is so fast and precise that the bat can distinguish between a stationary object and one that's moving toward or away from it. In essence, echolocation is not just a simple echo, but a complex, dynamic interaction between sound and the environment that allows bats to thrive in the dark. Now, after the bat emits its sound, it waits for the echo to return. But here's the twist. Bats don't just listen for any echo. They listen for the echo that's coming back from the object they're trying to find. This is called target echo selection. Bats can distinguish between echoes from different objects, and they focus on the ones that are most relevant for navigation or hunting. This ability to pick and choose which echoes matter is what makes echolocation so precise. It's not just about hearing sounds. It's about making smart decisions with the information they receive. In the end, this clever twist in echolocation is what sets bats apart. They don't just emit sound and wait. They actively interpret the world around them, one echo at a time. At the heart of echolocation is a complex interaction between sound waves and the environment. Bats emit high-frequency calls, which bounce off objects and return as echoes, allowing them to map their surroundings with incredible precision. These echoes are processed in the bat's brain, which can distinguish between different types of surfaces and even estimate the distance and size of objects with remarkable accuracy. This system is so advanced that some species can even detect the texture of surfaces, like the difference between a tree trunk and an insect, by analyzing the echo's shape and timing. Echolocation is more than just a survival tool. It's a sophisticated sensory system that has evolved over millions of years, shaping the behavior and ecology of these remarkable mammals. Imagine if your eyes were replaced by a superpowered sonar. You'd navigate the world by listening to echoes, not seeing. It's a bit like having a sixth sense, one that's perfectly tuned to the dark. Bats do this naturally, using their echolocation to find food and avoid obstacles. It's a tool so refined that it's more accurate than most human-made sonar systems. Think of it like a blindfolded person using a flashlight to navigate a room. They don't see, but they can still find their way if the light is just right. Bats have mastered this art so well that they can dodge flying insects midair, all while blindfolded, or rather, blindfolded by evolution. So, while it might seem dumb in a human sense, it's actually a brilliant, evolved strategy. One that's so efficient, it's hard to imagine anything better. Before you go, if you enjoyed this, please give it a like and subscribe so you don't miss the next one. And tell us in the comments what you'd like us to make next. We read every single one. Thank you so much for watching. Comment this emoji if you made it to the end.